Welcome back to MBSE Simplified. In the previous video, we talked about why requirements come first in MBSE. We saw why they must serve as the foundation of any effective model-based systems engineering effort. They define the system's intent, enable traceability, and prevent the model from drifting into speculation. In this video, we move from why to how. We'll explore practical techniques for writing clear, verifiable system requirements that integrate seamlessly into your MBSE model. You'll learn what makes a requirement strong, common pitfalls to avoid, and best practices you can apply immediately. Whether you're working in a requirements management tool or directly inside your model, let's turn good intentions into precise, actionable requirements. Knowing that requirements are important doesn't answer the next question: how do you actually write them? Because this is where most teams struggle, not with tools, not with modeling, but with turning system intent into clear, usable requirements. Shifting focus. Instead of asking, what is a requirement, we're going to ask, is this requirement usable by engineering teams? A requirement is only useful if it can be understood clearly, be implemented correctly, be verified objectively. If it fails in any of those areas, it creates problems downstream. Characteristics of well-written requirements.
Strong requirements share consistent qualities, drawing from established guidance like the INCO's Guide to Writing Requirements and ISO, IEC, IEEE 29148. Well-formed requirements are
necessary. They address a real need, not a nice-to-have. Unambiguous. Only one possible interpretation. Singular. One clear idea per statement. Verifiable. You can objectively confirm it through inspection, analysis, demonstration, or test. Feasible. Realistic given technical, cost, and schedule constraints. Completes. No critical gaps when viewed together. Consistent. No conflicts with other requirements. In MBSE, these qualities matter even more because your requirements become living elements in the model, linked to behaviors, blocks, and verification activities. A weak requirement weakens the entire traceability chain. Most good system requirements follow a simple structure. The system shall action, condition, performance. Example, the system shall transmit telemetry data within 2 seconds under nominal operating conditions. This structure ensures clarity, completeness, testability, strong line. A well-structured requirement removes interpretation.
Step-by-step method.
Let's walk through a practical method. Step 1. Start with intent. What is the system trying to achieve? Example, the system needs to communicate with ground stations. Step 2. Make it specific. What exactly must happen? The system shall transmit data to ground stations. Step 3. Add measurable performance. How well must it perform? The system shall transmit data to ground stations within 2 seconds. Step 4. Add conditions, if needed. Under what circumstances? The system shall transmit data to ground stations within 2 seconds under nominal operating conditions. Now you have a usable requirement.
Common writing mistakes.
Now let's focus on mistakes. This is where your video becomes valuable. Mistake 1. Vague language. The system shall operate efficiently. Problem. No measurable definition. Mistake 2. Design in requirements. The system shall use a cloud-based database. Problem. This is architecture, not requirement. Mistake 3. Multiple ideas. The system shall store data and transmit it securely. Problem. 2 requirements in one. Mistake 4. Not testable. The system shall be user-friendly. Problem. Cannot be verified objectively. If you can't test it, it's not a requirement. Even experienced engineers fall into these traps. Here are additional frequent issues and how to fix them. 1. Ambiguity and vague language. Bad. The system shall respond quickly to user inputs. Why it fails? Quickly means different things to different people. Fix. Make it measurable. 2. Mixing what with how. Solution bias. The system shall use a relational database to store user data. Why it fails? This dictates design instead of need. Fix. Focus on the outcome. 3. Compound or overloaded statements. Bad. The system shall authenticate users and log all access attempts securely. Why it fails: 2 ideas in 1 requirement. Hard to verify separately. BICs split into atomic statements. 4. Subjective or non-verifiable terms. Avoid adverbs like easily, robustly, or user-friendly. Also avoid absolutes like 100% reliable, unless truly required, and verifiable. 5. Inconsistent verbs or missing conditions. Mixing shall, should, and will creates confusion about priority. Always include conditions or qualifiers when relevant, e.g., under normal load, in extreme environments. When these issues creep in, your MBSE model inherits the problems, making simulation, impact analysis, and verification far more difficult. Best practices and templates for strong requirements. Follow a disciplined approach to write better requirements every time. Use a consistent syntax template. A proven structure. Subject shall action verb as abject under these conditions. Quantifiers. Example template. The system/component shall perform this action to achieve this outcome within these measurable limits. Recommended verbs: shall for mandatory, should for desirable but clearly flagged.
Specific and measurable. Bad to good.
Bad. The system shall be secure. Good. The system shall implement multi-factor authentication and lock user accounts after no more than 5 consecutive failed login attempts within a 15-minute period. Separate functional and non-functional requirements. Functional. What the system does. Behaviors, capabilities. Example. The radar system shall detect and track airborne targets at ranges up to 200 kilometers. Non-functional. Quality attributes or ILADs. How well it performs, performance, reliability, usability, security, maintainability. Example, the system shall achieve 99.95% availability, measured monthly with automated failover capability. Keep it concise and singular. Aim for 1 clear thought per requirement. Use active voice. Define all terms in a shared glossary. Add supporting attributes in your tool or model. Include priority or criticality. Include in verification method, test, analysis, inspection, demonstration. Trace links to stakeholder needs or parent requirements.
Share drafts early with stakeholders, designers, and testers. Use peer reviews or checklists based on in-course characteristics.
Requirements in the modal and model-based systems engineering. Requirements aren't just text in a separate document. They become model elements. Create a requirements package or diagram in SysML. Link each requirement to use cases or activities, behavior, blocks or parts, structure, test cases or verification activities. This built-in traceability lets you instantly see which behaviors satisfy which requirements. Impact of a requirement change on the architecture. Tools like Cameo, Rhapsody, or Capella make this visual and executable. Well-written textual requirements feed cleaner models, and strong models help you spot gaps in the requirements themselves. In MBSE, requirements don't sit in isolation. They connect to behavior, what functions exist, structure, what components support them, verification, how they are tested. When requirements are written clearly, the rest of the model becomes easier to build. When they are unclear, the model becomes unstable.
Real engineering challenges.
The hardest part of writing requirements is not the format, it's clarity of thinking. You need to understand the system, avoid assumptions, separate problem from solution, be precise without over-constraining. This is why requirement writing is a core systems engineering skill. Quick checklist and final tips.
Before baselining your requirements,
Run through this checklist. Is it unambiguous and singular? Can it be verified objectively? Does it avoid design solutions? Is it traceable to higher level needs? Does the full set remain consistent and complete? Remember, writing good requirements is iterative. Refine them as your understanding grows, but always keep them as the anchor for your MBSE model.
OOSEM Bridge.
This is also why structured methods like OOSEM begin with requirements, not diagrams, not architecture, but clear, traceable system intent. Because if requirements are wrong or unclear, everything that follows becomes harder. Mastering these techniques will make your requirements and your entire MBSE effort far more effective. If you want hands-on practice connecting well-written requirements to behaviors and architecture inside real SysML models, our SSA MBSE training program covers exactly that, including templates, examples, and tool workflows. Link in the description below. If this video helped clarify how to write stronger requirements, subscribe for more practical MBSE guidance. Drop a comment with one requirement you plan to improve this week. In the next video, we'll build on this by looking at how requirements are decomposed into system-level and subsystem-level elements. Thanks for watching. Now go make your requirements the solid foundation your model deserves. See you next time.